Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on analytical dynamics or classical mechanics, chapter variational principle, lecture number 6, in which I will give the concept of delta variations in classical mechanics. In the chapter of variational principle of classical mechanics or analytical dynamics, generally two types of delta variations are used. The first type is denoted by the symbol delta. This is the lower case delta, and this delta is the uppercase delta. This delta, lowercase delta variation is used in the case of Hamilton's principle. This is number one. Number two, this delta, triangular type, this delta variation is used in the case of principle of least action. Number three, the line integral in Hamilton's principle is I equal to integration time t1 to t2 limit L dt, and by Hamilton's principle delta I equal to 0, that is delta line integral limit t1 to t2 L dt equal to 0. Number 4, the line integral the principle of least action is I equal to integration limit t1 to t2 sigma I pi qi dot dt, and by the principle of least action this uppercase delta I equal to 0, that is delta variation of this integral limit t1 to t2 sigma I pi qi dot dt equal to 0. Now we differentiate the concept of these two types of delta variation Let A and B be two fixed points the system point may travel from A to B through many paths and we take the line integral along these paths and then use delta variations on the basis of following assumptions. We differentiate the two types of delta variations. The table is as follow. First column is serial number, second column is lowercase delta variation, and third column is uppercase delta variation. Serial number 1. For lowercase delta variation, at the endpoints of all conceivable paths, the position coordinates are held fixed. For uppercase delta variation, at endpoints of all conceivable paths, the position coordinates are held fixed. Means this concept, this assumption, same for both delta variations. Serial number 2. For lowercase delta variation, at endpoints of all conceivable paths, times are held fixed. For uppercase delta variation, at the endpoints of all conceivable paths, the times may be different and time of travel along different paths may be different. Along different paths means along different conceivable paths may be different. Number 3. In lowercase delta variation, the energy may or may not be conserved along the conceivable paths. In uppercase delta variation, energy must be conserved along the conceivable paths. Number 4. In lowercase delta variation, the conceivable paths are those paths in which the system point is sped up or slowed down in order to make the total travel time be the same. In uppercase delta variation, the conceivable paths are those paths in which the total energy be the same. Number 5. The paths which follow the concept of lowercase delta variation have the same value of the line integral I equal to integration limit t1 to t2 L dt. L be the Lagrangian function, that is delta I, lowercase delta I equal to 0. In uppercase delta variation, the paths which follow the concepts of uppercase delta variation have the same value of the line integral I equal to integration limit t1 to t2 sigma I pi qi dot dt. Pi be the momentum and qi dot be the velocity. Here qi be the generalized coordinate. That is uppercase delta variation of I equal to 0. The relation between the operators of two types of delta variation is uppercase delta variation equal to lowercase delta variation plus uppercase delta variation of t multiply d by dt, means derivative with respect to time. So we have compared and differentiate the two types of delta variations which are used in the concept of variational principle in classical mechanics or analytical dynamics. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.